Hi, welcome. So this is going to be a small demonstration, but before we go to the demonstration, let's do some calculations. So let's assume that I have a table, right? This is the edge of the table, and I have a bookshelf, something like this, and I would like to put the bookshelf over the table, and I want to move it to the right as much as possible, but I don't want it to fall off the table. Okay, so I hope you see that we can do this as long as, if this is a homogeneous mass, right? We can do this until the midpoint of the shelf, right? If you move it further to the right, it will topple off. If it moves further to the left, you can still shift it a little bit to the right. Okay, so this is called the center of gravity, and you can shift something until the center of gravity is just at the edge of the table. Okay, so if you look at the overhang, you will see that this is 1/2 of the width of the shelf. Let's make it a bit more interesting. So let's put two shelves. Okay, so if we put one shelf on top of the other, we can put the first halfway to halfway or the second, otherwise it will topple off. Okay, and now we put these two shelves on the table. So in order to see how far we can move both shelves over the table, we have to compute the center of gravity of this system here and put the edge of the table just below the center of gravity. Okay, so we put the 0 here. What's the center of gravity? Well, at distance 1/2, we have half of the mass of the object, right? So this is 1/2 times 1/2. And then the other half of the object, 1/2, will be at distance 1 from the origin. Okay, so this is 1. And then we have, this is 1/4 plus 1/2, this is 3/4. So if we move a distance 3/4 of the shelf, then we can put the edge of the table just here, because this is the center of gravity of these two shelves. Okay, so what's the total overhang is now 1/2. Okay, this is here 3/4, so this will be 1/4. So the total overhang is 1/2 plus 1/4. And this, if I can compute correctly, this is 3/4. Okay, so there's still 1/4 of the original shelf that's still over the table. Let's look at 3 shelves. So what do we have here? This is shelf 1. You put shelf 2 such that shelf 1 doesn't topple off shelf 2, and we put the third shelf here, the corner, at the center of gravity of the other two. Okay, so this system is stable, and then we put it on the table. How far can we shift this? Well, we can shift it until we hit the center of gravity of these 3 things. Okay, so let's compute it. Here, distance 1/2 is the center of gravity of this first shelf. So this is, at distance 1/2, we have 1/3 of the total mass, right? There are 3 equal shelves. And then at distance 1, okay, we have the center of gravity of these 2 things, so times 2/3. Okay, so this is 1/6 plus 2/3. So this is, if I compute correctly, 5/6. So let's say that this is somewhere over here. I don't know. So this is 5/6, and then this will be 1/6, right? Because it's the remainder of the shelf. You already know that this is 1/4, and this was 1/2. So the total overhang over the table will be 1/6 plus 1/4 plus 1/2. Okay, we can put this on the common denominator of 12. You have 2 plus 3 plus 6 is 11/12. So there's still some piece of the first board here that's still over the table. Okay, you can make 4 shelves, right? I have a big bookcase, so I have 4 shelves. This first one, this is my second one, the third one, and then the fourth one, I put it here, and then I put my origin here, and I would like to compute the center of gravity of this system of 4 shelves. So again, I'm going to split it up. At distance 1/2, I have 1, 2, 3, 4, 1/4 of the total mass. And then at distance 1, Okay, this is here. I have 1, 2, 3, the center of gravity of these 3 shelves. So at distance 1 I have 3 over 4. So if I compute this, I have 1 over 8 plus 3 over 4 is 7 over 8. Okay, so I compute here 7 over 8, and I put my edge of my table just here. Okay, so what's now the total overhang over the table? So I have 1/2. Here I had 1 over 4. Here I had 1 over 6, I think. And now here I have 1 over 8. So let's add all these numbers together. 1 over 4 plus 1 over 6 plus 1 over 8. And I put them on a common denominator. So here let's take 24. So I have 12 plus 6 plus 4 plus 3. It's 18, 22, 25 over 24, and now we see that this is bigger than 1. So the total overhang is bigger than 1, so this means that if I look at this line, the edge of the table, this entire shelf will be off the table. So when I had 4 bookshelves, my overhang was 1/2 plus 1 over 4 plus 1 over 6 plus 1 over 8. Okay, so let xn be the overhang with n shelves, so this is x4. So each time we get 1 over 2 times the number of shelves in addition. So I hope you see that in general xn will be equal to 1 over 2 plus 1 over 4 plus and so on until 1 over 2 times n. Okay, and you can write this as a sum from t1 to n of 1 over 2 times t. The 1/2 we can bring up front. Okay, so this is 1/2 the sum t1 to n of 1 over t. And here the sum, you see that this is nothing else than the harmonic sum that we have seen before in the lecture. So in particular, if n goes to infinity, this xn here will also go to infinity because it's 1/2 times something that goes to infinity. So if I would have an infinite number of bookshelves, the overhang would also be infinite. So in other words, I can make the overhang bigger and bigger and bigger by just adding more and more and more bookshelves. Now there's of course a catch, because the additional piece of overhang that you will get with an additional bookshelf will decrease by 1 over 2n. So in order to get, let's say, an overhang of 1 kilometer, you will need a huge number of bookshelves. So you have to stack probably higher than the atmosphere in order to get an overhang of 1 kilometer. Okay, so although it's mathematically possible to get an overhang of any number that you want, in reality this will not be the case. However, as we have seen that for x4 this overhang is bigger than 1, we should be able to at least demonstrate this. So this is what I'm going to do now. So I'm here in my office. I have 4 shelves of my bookcase, right, as you can see, quite heavy, and I'm going to slide them over the edge of the table in such a way that the top shelf is going to be entirely non-supported by the table. Right, so this outer edge of the table is going to be further away than the edge of the table. Okay, so I cannot do this both holding the camera in one hand and shifting the shelves in the other hand, so I'm going to take a few pictures and then I'm going to show you the end result. So you see the situation is a bit unstable, right? It's just the center of gravity is just right, but this last board is entirely off the table.